Marina Bay Sands, which was opened in phases from May 2010. At the heart of this development is the Marina Bay Sands Hotel, made up of 3 towers, crowned by the Sands Ski Park on the 57th story. Shaped like a boat perched at the top of the towers, the 1-hectare Sky Oasis has restaurants, sculptured gardens and an infinity pool. The building also houses a casino, theaters, exhibition space and the shops at Marina Bay Sands, with over 300 shops and restaurants. The Art Science Museum is a lotus-shaped museum that marries both art and science, resulting in unique, world-class exhibitions. A 280 meters bridge connects the 2 sides of the bay. Viewing platforms along the path portrays the city of Singapore. One of the primary design issues tackled by the architects and engineers was building movement. The unique design of 3 buildings connected by a ski park called for many engineering innovations. The dynamic properties of a tall building structure are particularly hard to predict as many elements contribute to the building movement. The wind engineers carried out extensive wind testing on the towers and ski park to provide the design team with the data necessary to develop the design approach. In addition to determining the loads for each tower in isolation, it was necessary to predict the behavior and movement of each tower relative to the others. This allowed for strategies to be developed for the steel span ski park, as well as to determine appropriate measures to guarantee the safety and comfort of the building users. The site and surrounding buildings were modeled at a scale of 1:400 and tested in a wind simulator. Mean and gust wind speed ratios were measured at 28 locations on the ski park model. The measured wind speed ratios were then combined with a statistical model of the local wind climate to determine the predicted pedestrian comfort in and Challenge number 1. Obviously, for such a project, its design has to be very unique. For this purpose, there was no better option than an architect like Moshe Safdie, who had designed structures with curved designs, and they are difficult to construct. Therefore, this design was a big challenge for the engineers and construction team. According to the construction team, it would take at least 7 years to complete the project. But the owner wanted to complete the project within 3 years. In these 3 years, the entire project with the 3 towers, its interior, museum, floating pavilion, and the most complex, Sky Park needed to be built. Accepting the challenge was a big achievement for the construction team. Challenge number 2. The site chosen for the construction work was full of soft clay due to the proximity of the sea, which engineers call it marine clay. The marine clay is exceptionally soft, and it is difficult to walk over it, let alone construct something, and if the marine clay is not treated correctly, then it can be disastrous. The feature of marine clay is that if some of the clay is removed using the excavator, the clay surrounding the ditch fills it quickly. Therefore, it was necessary to find out a solid solution so that the clay surrounding the ditch is not able to fill it. To address this issue, engineers decided to build a concrete wall of 1.5 meters thickness, which is also called diaphragm wall. 4,000 meters diaphragm wall was constructed, with a depth of 50 meters below the ground. And with the help of excavators, the marine clay was removed inside them. It took engineers 1 year to remove the marine clay. Challenge number 3. Now they were left with 2 years to complete the project. The engineers detected a major fault, which resulted in the delay of the construction of the Sky Park. As all the 3 towers were built independent of each other, that is, there was no connection between them. That is why engineers believed that during strong winds the buildings might swing in different directions. And if the Sky Park is constructed despite this, it could be disastrous. After months of brainstorming, a solution was found. Utilizing the bridge engineering technology, it was decided to introduce movement joints, where the entire Sky Park will be built upon a steel bridge, laid over the 3 buildings. Special movement joints will be installed in this steel bridge, which could absorb up to 250 mm movement. Challenge number 4. The complication for the construction of the 3 towers was that one portion was straight and the other one was curved at a certain angle. And both parts will stand in support of each other. On paper, it looks easy, but practically building this was a challenge that nobody has ever tried anything like this before. If it is not constructed with proper planning and calculation, then the weight of the curved portion might break the straight portion, as you can see in this domino effect. To implement this design practically, engineers found a very effective way. With the help of concrete blocks, a floor was erected every 4 days. Steel wires were inserted inside the curved building for support, and as the height of the buildings increased, both the buildings were given temporary supportive steel frames. It was 23rd floor where the curved portion met the straight building there. With the help of a heavy steel truss, both the portions were joined and the steel frames were removed. Conclusion. The principal challenge for the Marina Bay Sands project was the combination of complex design parameters matched with a very fast project schedule, from initial sketches to substantial completion within 4 years. This meant arranging close and intensive relationships between the engineering, construction management and design teams on site, such that coordinated solutions could be quickly negotiated as they arose. The success of the project lies in the fact that the inventiveness of the design was matched by an equally inventive and novel approach developed by the engineering and construction teams.